Hey there, thanks for watching. I'm glad you're watching this review rundown here. So this is our review practice page. So the first couple problems are solving a system of nonlinear equations. All right, there's a line and a parabola, and over here it's two parabolas. So I've got a lot of algebra steps marked off here. There's definitely more than one way to solve this. Any way you do starts off with kind of putting the two expressions equal to each other like this, most likely. And then if you want to kind of take your time, make sure that you're following order of operations. You do not distribute this -2 inside this binomial. Don't even think of doing that. Follow order of operations. I worked it down so that I could factor the trinomial here to get my x values. You take those x values and you plug them in. I plugged them into the linear equation because it seemed easier. And I got two different y values, and the solutions then are when x is -4, y is -11, and when x is 1, y is -1. So there's my solution. And the line crossing the parabola in two places, and these are the coordinates of those two intersection points. Like I say, stop the video if you want, pause it, and check out the algebra here. Take it one step at a time. This one's a little bit simpler algebra because these two expressions, when you set them equal to each other, work out nicely to a factorable quadratic. Two x values from those factors. Again, plug them in to get the y values, and it so happens, coincidentally, that the two y values are the same. And if you look at a graph of both of those parabolas, you'll see why they're the same. Anyway, that's how those go. There will be one of those on our test. So here's a problem about writing an equation really of two circles from a graph. And so the big one here, the center is at -3, -4, so my equation is x plus 3 squared plus y plus 4 squared equals 16, because the radius is 4, and 4 squared is 16. The area of that circle is 16 pi. The equation of the small circle, using its center, which is right there, -3, -6, gives me that equation. The radius is 4, so the area is 4 pi. The area in between them is the big circle minus the little circle. 16 pi minus 4 pi is 12 pi. Okay, that one's pretty easy. Here's a problem finding the length of a chord given the arc measure and the radius. So the radius is 14. I don't know if this is in focus for you guys, if you can see this. I hope so. Anyway, the arc measure is 80 degrees, which when you split that in half by drawing the altitude down here in this triangle, this is the two radii plus that chord make an isosceles triangle. The altitude of that splits the chord into two equal parts, bisects the chord, and it also bisects this angle. So it was 80 degrees, but now it's only 40 when you split it in half. So it's a right triangle there, and the sine of 40 degrees is the opposite over the hypotenuse, x over 14. You work that equation out, and you get 9, pretty dang close. It's 8.999, so I just rounded up to 9 for the x value there, and that means the chord is twice that, or just about 18. Okay, I'm going to flip this over. All right, so quadratic inequalities. Okay, so I'm kind of expanding our view of this a little bit. Before you even do anything with this, stop and think about what this might look like on a graph. It is regardless of where it's located, it's a positively oriented parabola. A positive number here means the parabola is opening upwards. All right, so it's going to cross. If it crosses the x-axis, which these do, if it crosses it, it's going to cross it in two different places. So it'll be something kind of like this. All right, it's less than 0 in this inequality. So the place where this parabola is less than 0 is where the parabola is below the x-axis. We've used a number line in the past and put a little plus, minus plus, or whatever, testing values between those two numbers. But before you even get to these numbers, I want you to think about what this graph would look like in relation to the x-axis, and what that means with the inequality symbol here, what that means you're looking for. When this is less than or equal to 0, you want the place where the parabola is below the x-axis, and that's in between these two numbers. All right? So our solution is going to be from this number to this number. And then the process of finding those two numbers, that's what you do with the algebra. But conceptually, it's really important to have that in mind. I'm not even going to do it yet. The other one is an upside down or negatively oriented parabola. It's crossing the x-axis some kind of sort of like this, right? And this is also less than 0. Well, look at this. Where this is below the x-axis, less than 0, that's this region and this region. All right, this is actually a parentheses, not an arrow point. It almost looks like an arrow. Okay, but it's from this number to infinity is one part of the solution, and from negative infinity up to this number is the other part of the solution. So this is two separate regions for the solution to this inequality. So you got to find these two numbers, right? So let's go back to the first one there. I'm solving this quadratic as if it were equal to 0. This is just kind of to help me find these two numbers here. I set it equal to 0 and solve it. And you can, again, stop the video here. I added 1 to both sides. I then divided by 0.5, okay? So when you divide by 0.5, 1 divided by 0.5 is 2, okay? And that just gets rid of the 0.5 there. So when I take the square root, see, I'm taking advantage of this x minus 4 squared thing. You don't have to. You could multiply it all out, use a quadratic formula or something like that, or factor it. And so I'm taking advantage of the squared binomial there. Taking the square root of both sides makes the algebra pretty simple. 4 plus or minus the square root of 2 is my answers. So there's 4 minus the square root of 2, and here's 4 plus the square root of 2. I've expressed the same solution in two different styles. This is kind of an interval style with the brackets because that's less than or equal to. And then over here with the inequalities, it's the same thing, okay? So I'm just expressing this region between those two numbers as my solution to the inequality. Over here, when I go through that process, I get these two numbers, and I'm not going to belabor the process here in this video, but when you solve that inequality, you get negative 4/3 and positive 3. So there's your two zeros of this quadratic inequality here, and the solution is from negative infinity to negative 4/3, that's this spot, this region here, and from 3 to infinity, that's this region here. Please make note that you cannot express this these two separate regions with one inequality statement. It has to be two separate statements because it's two separate regions. Okay? All right, moving on. Find the radius. This is like the other problem on the other side of the page, only this time we are given the arc measure and the chord length and asked to find the radius. Okay? As I mentioned in the notes, if you have two of those things, you can find the third. Two of those things meaning either the arc measure, the chord length, or the radius. Those three things all play together, and if you have any two of them, you can find the third one. Again, by splitting it into a right triangle. In this case, we've got the base here, the opposite side, and this angle, 55 degrees. So the sine of 55 is opposite over x, 9 over x, I mean. And you work that out to get about 10.9 is the radius. Okay, last but not least, writing these two standard form equations into center radius form. Pretty simple, I hope. Actually, let's do B first. It's a little bit easier. Half of that squared is 49. Half of that squared, sorry, they're 14. Half of that squared is 9. So I'm going to add 49 and 9 to this other side. Make sure you see I'm moving this 21 over here makes it negative 21. Then you put all this together and you get positive 37. You factor this trinomial here to x plus 7 squared and this one to y plus 3 squared. So our center is negative 7 and negative 3, and the radius is the square root of 37. I wonder if you can hear the rain in the background. It's really nice. Anyway, this one, doing the same thing, completing the square. Half of 5 is 2.5, and 2.5 squared is 6.25. So I'm adding 6.25 to both sides of this equation. Half of 1 is 1/2, and 1/2 squared is 0.25. So I'm adding also 0.25 to both sides of this equation. When I move this negative 9.5 over there, I add all of that stuff up to get positive 16, and so my binomials here from factoring these perfect square trinomials, x minus 2.5 squared and y plus 0.5 squared. So my center point is positive 2.5, negative 0.5, and the radius is 4. All right, that was it. Have a good afternoon. Please, if you have any questions about this video, just go ahead and put them right into the forum thread that you will see this video posted in. Okay, have a good afternoon. See you tomorrow. Bye-bye.